this video, we will be discussing about minimum operations to exceed threshold value 2. You are given a zero-indexed integer array nums and an integer k. In one operation, you will take the two smallest integers x and y in nums, remove x and y from nums, add minimum of xy into 2 plus maximum of xy anywhere in the array. Note that you can only apply the described operation if num contains at least two elements. Return the minimum number of operations needed so that all elements of the array are greater than or equals to k. So what they are saying is that in the input, we are given an integer array nums and we are given another integer k. Now what we need to do is that we need to find out the two smallest elements from nums, right? And then we need to remove them from nums. Then considering them as x and y, we need to find out the value of this particular equation. Then whatever is the value that we get from this equation, that has to be inserted into nums anywhere. It can be inserted anywhere in the array. The position does not matter. Now this process has to be repeated until all the elements in the nums does not become greater than or equals to k, right? Then whatever is the minimum number of operations required to make all the elements in the nums greater than equals to k, that we need to return as our answer, right? So if we see over here, right now there are some elements which are smaller than k, which is 2, 1 and 3. Then that means we will have to apply the operation, right? So what we will do is that we will pick the two smallest elements from the nums, which will be 1 and 2. So x will be 1, y will be 2. If we find out the value of this equation, then the minimum of x and y is 1 into 2 plus maximum of x and y is 2. So it will be 2 plus 2, that is 4. So 2 and 1 will be removed and 4 will be inserted anywhere into the array. So our array will now look something like 4, 11, 10, 3. Right now also there are some elements which are smaller than k, which is 4 and 3, right? So we will again have to apply the operation. So we will pick the two smallest integers, right, which is 3 and 4. So x is 3, y is 4. Minimum of them is 3. 3 into 2 plus maximum, that is 4. So 6 plus 4, that is 10. So 3 and 4 will be removed and 10 will be inserted. This is how our array will look like now. Now if we see all the elements are greater than equals to k, so now we have to stop. So how many operations we did? First operation and the second operation, right? So for this particular case, our answer will be 2. Right? Now how to solve this? If we look at the brute force or the naive approach, that doing what they are asking us to do. So first of all, you will do the operations while all the elements does not become greater than equals to k, right? So maybe you will run a while loop and inside this you will check that while all elements are not greater than equals to k, you keep on doing these operations. And how you will check this? Maybe you can define some function in which you iterate over all the elements and then check that if all the elements are greater than equals to k or not, and return true or false accordingly, right? So basically for checking this, you would be running a loop n times, right? This will take n times. Then inside this, you need to find out the two smallest elements from the array. Right. Now for finding out the two smallest elements, either you can sort this array, which will take n log n time, or you can iterate once in this and you can keep the track of the smallest and the second smallest element, right? So this can either take n log n time or can take n time, right? Then after you have find out the two smallest elements, you will remove them and they can be present at any position. So let us assume this will also take n time, right? Then you will find the value of the new formula and then you will push it back into your array. These we can consider as constant, right? And then you can keep the track of the operations. This will also be constant, right? This is the approach that we can follow. Now assuming that this you are implementing with n time, so overall this will take n into n time, which is n square, right? And n square will not work over here. So what we can do is that we can make few observations from this code. See, we are checking all elements are not greater than equals to k. Instead of checking for all the elements, why not we just check for the smallest element? If I pick the smallest element from the nums, right? If I pick the smallest element and that element is greater than equals to k, then whatever are the other elements in my nums, they will always be greater than equals to k because I have picked the smallest element. And if it is smaller than k, then obviously I will have to apply the operation, right? So here, instead of checking for all the elements, we can just check for the smallest element, correct? Now this operation we'll have to do that, okay, find the two smallest elements, remove them, find the value of the formula, push it and increase your operations, right? So now if you look over here, at each and every point, we are concerned about the smallest element or the two smallest elements from our nums. And when we are pushing the new value into the nums, we are not concerned with its position, right? So what we can do is that we can maintain some kind of data structure which gives us the smallest element in less time, right? And what is that data structure? Min heap, right? Because min heap keeps the smallest element always at the top, right? So what we can do is that we can take a min heap which will be implemented using a priority queue, and in this we can insert all the elements of the nums. So it will look like 1, 2, 3, 10, 11. This is how the elements will be inserted into the min heap. The smallest element will be at the top, right? Now what our code will look like? Now here we can check that while the top element is less than k, because if the smallest element is less than k, then we need to keep on repeating our process, right? So this can be our condition. Now this accessing the top will be constant, right? See, earlier it was taking n time, now it is constant. Now inside this, what do you want? You want the two smallest elements, which will be the top element, and then when you will pop it, then the next top element, right? Now in the question it is mentioned that the input is generated such that it is always possible to create an array where all the elements are greater than equals to k after some number of operations, right? So since it is always possible, then that means you do not have to explicitly put a check that when I have popped the top element, then for the next element you don't have to put a check that my min heap is not empty, right? So we can just take the top element, right? We'll take the top element, this will be x, and then we can pop it, and then we can again take the top element which will be y, and we can pop it, right? So this will give you, and then we will find the new value with the formula, and then whatever it is we will push it back into the heap, right? And then we can count our operations, and this is what we will do, right? So if we look at here, first of all, what we'll do, we'll check is the top less than k. So 1 is less than k, so yes it is, it will come inside. So in the x, we will take the top element. So x will be 1, and then we will pop it. So x will be removed from here. Then in y, we will take 2, and 2 will be popped from here. Then we will find the new value, which will be 1 into 2 plus 2, that is 4. Then this 4 will be pushed into the min heap, right? So our min heap will look like this, right? And then we will increase our number of operations by 1. Then we will again check this condition. What is the top element? 3. 3 is less than k, so we will come inside. So now x will be 3 and 3 will be popped from here. Y will be 4. 4 will be popped from here. Now we will find the new value, which will be 10. So 10 will be pushed over here, and our number of operations will be increased by 1. Now we will take what is the top element, that is 10. 10 is less than 10? No. So we will come out of the loop, and at the end we can just return this 2 as our answer. So see how much we have optimized our time complexity. Here we are checking this condition in constant time, right? And then here we are popping and pushing the elements, right? Now the popping and pushing operation in the min heap takes log n time, right? Now initially we had inserted all the elements of nums into the min heap, right? So you would be running a for loop for all the elements, which would take n time, and then you would have to push it into the min heap, which will take log n time, right? So we can say that here the time complexity will be order of n log n, right? And what about the space complexity? So we have taken an extra space of min heap over here, in which we are inserting all the elements of nums, right? So our space complexity will be order of n, right? So now let's look at the code. So first of all, we will have to create a min heap, right? Which will be implemented using a priority queue. So we will take a priority queue over here, and since the element can become large when we do the multiplication with 2 and add it, right? So for that we will take a long over here instead of integer, right? And by default priority queue creates a max heap, so we will also have to write over here vector long comma greater long, so that it creates a min heap for us. Let's name it PQ. And then in this, we want to insert all the elements of nums. So here in the bracket, what we can do is nums dot begin, comma, nums dot end. So this will push all the elements of nums into the min heap, and this will take n log n time, right? Then let's create an answer variable for storing our answer, basically the number of operations, and we will initialize it to 0. Then we will run a while loop that while pq.top is less than k, keep on performing the operation. Take the top element, which will be long x equals to pq.top, and then we will pop it. Then take the next top element, which will be long y equals to pq.top, and then pq.pop. Right now, we want to find the new value and push it into the min heap. So we will do pq.push minimum of x comma y into 2 plus maximum of x comma y, right? And then we will increase our number of operations by 1, and at the end over here we will return our answer. So let's run this. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.